Isn't this absolutely spectacular? This is one of the finest sites in all of Donegal for physical geography. This is the U-shaped valley in the centre of Glenveagh National Park, in the middle of what's known as the Donegal batholith. Now, the Donegal batholith is a large lump of granite that comprises the centre of the county, and at its heart, this gigantic tear in the Earth's crust, which joins up with what is Loch Ness in Scotland, forms a huge glaciated U-shaped valley that stretches on out from here to the coast. Now, what's amazing about this valley is that the rocks on both sides of it are starkly different. The rocks on the left-hand side come from about 30 miles further down south from us. The rocks on the right-hand side come from this location. What this is an example of is a fault line moving laterally. In other words, the rocks doing this past each other on the Earth's surface. They're both made of granite, but from two different locations. They have been moved up to meet each other over the mountain building process that took place in Donegal 66 million years ago that gave us this granite. We're on top of a truly ancient mountain range. To give you an idea of the heights of some of the mountains here, these ones out behind me here are between 600 and 750 metres above sea level, which isn't huge globally as far as mountains go, but you need to remember that this is the base of an ancient mountain that used to be higher than Mount Everest. The amount of rock that has come off the top of these mountains measures in the miles. And at one point in Earth's history, this mountain chain, which we're now sitting in the middle of, which joins us to Scotland and Norway, the coast of North Africa, its counterpart, its other half, is on the other side of the Atlantic Ocean, what makes up the eastern United States, the Appalachian mountain ranges, which stretch down to Florida through New York State, and also some of the coast of Greenland. It's a truly epic story in Earth's history, and to sit in a place like this and look at it on a sunny day, you go, that's a nice view. But to truly understand what happened here, you need to do a little bit of research, a little bit of digging, and really get to know the landscape. And then you begin to become aware of the sheer gravity of what you're standing on and how amazing that actually is. So it's been wonderful to share this particular site with you. Again, this is one of the few sites in Donegal, like I said, off the beaten track that not many people get to see, particularly now that the Wild Atlantic Way takes you along the coastline, which is no less spectacular. But this is one of my favourite. So breathe it in for a few seconds more, and in the next little clip I'm going to be talking to you about the minerals that make up the mountains behind me, up close and personal, in another fantastic little location not too far from me. What's below me here is a beautiful example of the white granite you find in the centre of the Donegal Mountains. The granite gets its colour from the mineral known as feldspar. Feldspar comes in a number of different colours and a number of different crystalline structures. However, this one here is the white variety of feldspar, part of the felsic minerals group. Now, there's a large proportion of this rock made out of that material. There's also quartz in there, which is, its chemical composition is SiO2. It's a fairly basic mineral. It's also the most common mineral on the surface of the planet. SiO2, or silica, occurs in this rock along with the feldspar and another mineral called mica. Mica comes as flakes that are very translucent in the sunlight. Sometimes you can get sheets of it large enough, like those that occur just outside of Moscow, that you can build windows out of it. But the mica that occurs in here is fairly small, comes in tiny little quantities, and I'm just going to hold this up to the camera so you can see the dark flecks. The dark flecks on this piece of white granite is the mica. The rest is comprised of quartz, whether it's milky colour or clear, and the white feldspar that produces that overall white colour. What's great about feldspar and granite is that it comes in all different colours. You can get brown, green, purple, red. You can get little tinges of the white and some cream as well. It produces a wonderful spectrum of different types of rocks to look at. This, however, is one of the most striking. What I also want to show you is that this here came from a recent landslide, so it's been freshly exposed. That's the mineral, that's the rock surface as it was at the end of the last ice age. This is what it looks like on the surface after it's been eroded and then covered in native plants like mosses and lichens that you see before you here. A kind of browny colour. Underneath it looks like this. So that's a little introduction into what makes up granite. What gives granite its overall hardness is the fact that the minerals that make it up are themselves incredibly tough. Almost up at 6 or 7 on the Mohs scale. These types of minerals here resist weathering excessively, unless of course you have a very, very high temperature climate, like the kind of climate you find in the Sahara Desert. Most of the Saharan sand comes from sandstone and granites that have been eroded in the higher temperatures. Up in this part of the world here, the granite doesn't erode as fast. Sometimes, unless you're talking about an ice age, it doesn't erode at all. So the age and the durability of these mountains owes itself to the minerals that make up the rock itself. That's a little bit about granite. The next little video we're going to give you here is just showing off different crystal structures within the granite itself and all of the fantastic sparkly little bits and pieces that are contained in there. Talk to you soon. I'm sitting here at the base of one of the large granite mountains in the Donegal batholith, and beside me here I've got some rocks with examples of two different types of mica, feldspar and quartz that you would normally get up in these rocks. I'm going to show you first this shiny one. I love sparkly rocks, I always like shiny rocks. This one contains a type of mica called muscovite, and it's normally clear. And this form here, and what you mostly get in the Donegal mountains, it's kind of opaque. It's not exactly see-through. This particular mineral is formed in rocks and layers, so it comes like pieces of rock, and it can come away. If you get big enough examples of it, it comes away in flakes. This is normally how it occurs. So if you're out and about and you find a lump of rock that looks like it's filled with sparkly dust, this is what you're looking at. This is mica. The other type of mica I have here, which you also get in the Donegal mountains, is biotite. Now, biotite is the dark version of mica, and you can see it in the rock here. It's got nice little layers. Although this rock's fairly eroded, this came from a riverbed, you can see a decent chunk of it there, and hopefully on the video you'll be able to see that reflecting the light as it goes. It's the one part of granite that is its main weakness because of this tendency for biotite and muscovite to flake away. It's the thing that allows erosion to get into the rock in the first place. I have an example of that here. This is like blue peter. Here's one I made earlier. This is a lump of quartz that contains biotite that's been excessively weathered because the biotite's been plucked out as a result of water action at the bottom of a river nearby here. And you can see the pock marks all over the place where the biotite's been scooped up by the action of the water and taken away, leaving the harder quartz behind. This is granite's Achilles heel. This is what begins the weathering process for granite. What we've got here is another example of muscovite, again, really, really shiny. Think sequins on a dress. That's what you're looking at when you're looking at muscovite on a rock. It's very, very beautiful. And this particular rock, but this isn't granite per se here, this is a metamorphosed rock. An awful lot of metamorphic rocks also contain large quantities of biotite and muscovite. Now, for a textbook example of what granite looks like, whether you're slicing it very thin to look at it under a microscope, or whether you're looking for it out in the field, this would be it. This is another piece of the white Donegal granite that we were talking about earlier. And it has the tiny little flecks of biotite mica, and then you've got the creamy colour, which is pockmarked all around here. That's white feldspar. And then you've got these little more opaque, sort of almost translucent pieces. That's the quartz. And again, it's the feldspar that gives the granite its unique colour. And this particular one happens to be white. This one little rock which I found, you always find interesting things when you're out and about. This rock is actually a piece of the old cap rock that used to be on top of the granite, and it's filled with mica. It's been excessively mineralised and probably baked hard when the granite welled its way up through the crust to create the base of the Donegal mountains. But in this, if you can just about make out, there are very, very tiny flecks of rust, indicating iron. Now, this relates to some of the later videos where we'll be looking for effects of mineralisation and the signs of mineralisation in rocks to let you in for what might be in them that will be of any use to human beings, like for example silicon here, or in this case iron. You've also got little granite or little garnet gemstones pockmarked through that as well. So it's really beautiful and magical, even though it's a small example. So, hope that gives you some of the grounding you're going to need if you're interested in granite mountains and what you're actually standing on when you're walking out and about. And in the next video I'll be taking you through a metamorphosed rock that makes up some of the most beautiful mountains in the ranges in Donegal, and that's quartzite. So see you soon, and hope all goes well.